Hey everyone, welcome back. Today we're tackling a fun medium problem from Leetcode, minimum number of operations, to make all array elements equal to 1. It sounds a bit tricky, but don't worry, we'll break it down step by step. So here's the official problem description. The goal is simple. We get a list of positive numbers, and we need to turn them all into the number 1. The tricky part is the special rule we have to follow to do that. To put it simply, we start with a list of positive integers. Our only mission is to make every single element in that list a 1, and we have to do it in the fewest possible steps. The only tool we have is the GCD, or greatest common divisor. We can pick any two numbers that are right next to each other in the array. We calculate their GCD, and then we can replace either of the original numbers with that result. So for example, if we have a 6 and a 9, their GCD is 3. Our list could become either 3 and 9, or 6 and 3. This is the only move we can make. Let's walk through the first example, a list with 2, 6, 3, and 4. The key insight here is that to make progress, we need to create a 1 somewhere. The fastest way to do that is to find the smallest group of adjacent numbers whose combined GCD is 1. Looking at pairs, the GCD of 2 and 6 is 2, no help. The GCD of 6 and 3 is 3, nope, but the GCD of 3 and 4 is 1, perfect. We found our starting point. Okay, so our strategy has two main parts. First, we have to create a 1. We saw that the pair with 3 and 4 has a GCD of 1. It takes just one operation, let's say, replacing the 3 with the result, to get a 1 into our array. Now, our array looks like 2, 6, 1, 4. Step 1 is done. Now for step 2, we spread that 1. Since the GCD of 1 and any other number is always 1, we can just use our new one to infect all its neighbors. There are 3 other numbers, so that will take 3 more operations. So 1 operation to create the 1, plus 3 operations to spread it, gives us a total of 4. Now, let's look at the second example. A list with 2, 10, 6, and 14. Notice anything? They're all even numbers. If you take the GCD of any 2 even numbers, the result will always be an even number. It's impossible to ever get an odd number, let alone the number 1. So in this case, the task is impossible, and we should return -1. This leads us to a clear thought process for solving the problem. The very first thing we should check is the easy case. Does the array already have a 1 in it? If so, great. Our job is much simpler. If not, we should check for the impossible case. We can do that by taking the GCD of the entire array. If that's bigger than 1, like in our all evens example, we know we're stuck. And if neither of those is true, then we're in the standard case, where we first have to figure out the cheapest way to make a 1, and then spread it. Just a quick heads up. We'll be walking through the solution using Python, but don't worry if that's not your main language. I'll be showing the full code for other popular languages like Java, C++, and JavaScript towards the end of the video. So the approach, which the editorial calls a greedy strategy, is really just following that thought process. We'll handle the simple cases first. If the array already contains 1s, we just calculate how many numbers need to be changed. If it's impossible, we return -1 right away. Otherwise, we find that shortest possible subarray that can produce a 1, and we use its length to calculate our final answer. Okay, we've talked about the big picture and the logic. Now let's see what this looks like as actual code. I'll put the full solution up on the screen first, and don't worry after that, we'll walk through the most important sections together. Alright, here's the Python code for this greedy approach. It might look a little dense at first, but it directly follows the 3 cases we just discussed. Let's break it down piece by piece. First up, we handle the easy wins. We count how many 1s are already in the array. If there's at least 1, we know we don't need to create any. The number of operations is just the total length of the array minus the number of 1s we already have. Next, if there are no 1s, we check for the impossible case. We calculate the GCD of the entire array. If this overall GCD is greater than 1, we return -1. If we get past those first 2 checks, we're in the main scenario. We need to find the length of the shortest subarray, whose GCD is 1. We do this with a classic nested loop. The outer loop picks a starting point, I. The inner loop expands a window from I to j, calculating the GCD of that window as we go. As soon as that GCD hits 1, we know we've found the shortest possible subarray starting at I. We record its length and break the inner loop to move on to the next starting point. After the loops finish, we'll have our variable, min_len, holding the length of that shortest magic subarray. The final answer is calculated with this formula. The minimum length, plus n, minus 2. Remember why? It's the min_len-1 operations to create the first one from that subarray, plus the n-1 operations to spread that one to all the other elements. So, how fast is this? The time complexity is big O of n squared log m. The n squared comes from our nested loops that check every possible subarray. The log m part is for the GCD calculation, where m is the biggest number in our input array. For space, it's fantastic. We only use a few variables to keep track of things, so it's big O of 1, or constant space. Alright, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down, so just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. Hopefully seeing it in a few different languages helps solidify the concepts. So let's wrap it up. The key takeaway here is to always look for edge cases first. By handling arrays that already contain ones, or arrays where it's impossible to make a one, we simplify the problem a lot. The main logic then boils down to a two-step process. Find the cost to create the first one, then add the cost to spread it to everything else. Alright, before we jump into the other languages, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily Leetcode problem. You know the drill. So I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with the little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads, and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now, while it's all free, are yours to keep and use forever. So it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems, so if you're serious about your interview prep, be sure to check it out. The link is in the description below.